We already went over the answers to 2 and 4. 10 was no, yes, and now number 20. Why? Oh, hold on. Shh. Thank you.
Since it's x equals 1, you just go over 1 on the x-axis and make a
Make it. Exactly.
So that doesn't pass the vertical line test because it goes through a point that you can
Yeah. For the vertical line test to work, you have to take a certain x and make sure there's only one point there. But a vertical line has how many points at one x?
A lot.
Infinitely many. So how much does it fail? Infinitely. Well, that's pretty bad. But either way, it would fail if there was just 2. So either way it fails. Yes, it fails worse than, but it's still just a failure. In the sense of being a function. Not, never mind. There's a life lesson in there, but we'll skip. X equals 1, not a function. Why? It's a vertical line, and vertical lines fail the vertical line test. They do not just have 1 point per vertical line. Number 36 was a piecewise function. You guys had to figure out which piece to plug in. So check real quick. Did you get 8 and 5 and 0 and 1 and 2? And if you didn't, check to see which piece you plugged it into. It might have been the wrong one. And these ones, we had to think about the inequalities, think about the numbers that were represented, and plug into the appropriate piece. Maybe have a table down below summarizing, but did you get the right one? If not, my advice, put a quick slash through, write the right answer, and then if you have time, go and look and see if you plugged into the right piece. Number 56. What was the domain problem? Denominator. What's the denominator not allowed to be? Got it. Nicely done. So what do we do to say where the denominator, what the domain is? We find those zeros that are not allowed. Remember? Denominator not equal to 0, straight out of the notes. Some of you made the mistake of not factoring. If you added the 2x and divided, you would have gotten the 2. You just wouldn't have gotten the 0. So when you factor, set each one equal to 0. X equals 0? Yeah. X minus 2 equals 0? Yeah. Those are the places where the domain cannot be. Does anybody have a cool shortcut notation of writing this entire sentence using what I did yesterday in class, or just your knowledge of? How do you say all real numbers except 4?
You do the fancy R.
Yeah.
And then I put like a not equal sign.
Exactly. That's exactly what I was looking for. You could totally say the exact same statement by just, now, yesterday, if you are following what I do the quick little D for domain, because if they were to ask range, I could go ahead and just label both of them quickly. If you wanted to do set builder notation, you totally could. You could say all values of x, something to the effect of, this is what Jason was saying, all real numbers. You could say except, you could say but, x not equal to 0 and 2. Totally fine. But to be honest, technically, if you give me x does not equal 0 or 2, I'd be fine with that too. Why? Because I would assume you mean all real numbers but. Okay? Because we're not even talking about imaginary numbers yet. So yeah, that would have been totally fine to shortcut that. All right. Oh, who did I skip?
66.
Because I have them on the other page. We'll talk about them. I know. 68. 68. I just want you guys to get the answer down. I'm pretty sure you have a question on him also, and that's totally okay. But the end answer is between 0 and 6. I think they were asking for the A formula and then the domain. So the A formula ends up being 2x square root of 36 minus x squared. The domain ends up being 0 and 6. 66 and 68 were very complicated problems. They were. So I'm pretty sure we have questions on them. We'll come back. Oh, I thought there was another even. No, that's it. Oh, that was it. Okay. I'm going back to the notes because I'm pretty sure I have in the notes, so which one's you? Not that one. There we go. I'm pretty sure I have some questions already ready, including 66 and 68. But my question to you first is, do we have any questions earlier than 66 on evens or odds? I'm trying to get your guys' book open. Sorry if you're wondering why I'm not looking at you. Okay, any questions earlier than 66? Yeah, Tyler. Okay, like how to analyze what they were giving you? Okay, so let's start with number 10. Hopefully my book Here we go. Pulls up, which it did. Let me get rid of this guy. Number 10 was weird because it gave you variables, right? And I think we just graded that one, and that was the, what, no, yes, no, yes. Was it that one? And here's the reason why. If you look at what was going on here, if we're going from A to B, and as you look at your ordered pairs, it kind of helps too. A is all the x values because they come first. That makes sense, right? And B is all the y values. And so what they're trying to say is it doesn't really matter whoever's in this spot. When you go looking at the set of ordered pairs, what you have to be on the lookout for is any x that's repeated, because a function isn't allowed to have same x be with different y's. So that's why that one fails. As you go looking here, none of the x's are repeated, so they're each with a unique y, so we're okay. As you go here, wait a minute, all of a sudden they just made all of these the y values. But we don't really care even if the y values are repeated, because really, who are we still just looking at? Yeah, and since no x is with a different y, like you saw here, well, this one passes. It wasn't about whether or not these letters are repeated, it's whether or not the x's are repeated. And this one fails because... No, it passes. Wait a minute, hold on. Did they just write them weird? No x's are repeated, that one passes. No x's are repeated, that one passes. Which set of ordered pairs represent functions from A to B? Ugh. I don't like letter C. Because they tell you that A's are X's and B's are Y's 1 second, and then they change the order the next second and expect you to be able to do that. We do ordered pairs the same way. Can you guys just write a line through letter C? I don't know why that question's never come up before. Good question, Tyler. Because didn't the answer key say that one was a no? Yeah, no, I don't agree. This one's a yes. Because each X is paired with one and only one Y. They wrote it in the order of the numbers before the letters. They made these guys Y values. They kind of like went back on their word in a sense. So cross out C. But technically, I would say C is a yes. They were trying to trip you up with what they said here, looking different than what's down there. That's just nasty. Mean pre-cal guys. All right. Anything else before 66? Okay, let's go see it. I think I have it right here, ready to go. Now pause. If you're supposed to write directions and problems before you even go about solving, what could you, should you guys have written for number 66 without even having to know exactly what to do? Yeah, summarizing the paragraph. What would be a good way of summarizing a paragraph? We have a box, maximum, yeah, I would have done that. Combined length and girth equals 108. Now, this, even just the clue got nasty. In notes, weren't we talking about the iced tea can, and it was like the ratio of the height to the radius is 4, and that was our clue, and that was important? This clue is crucial, or else you can't really do B or C. Been able to kind of, not B or C. So this clue is crucial, but it's nasty. Girth. I want you guys to, if you did write the word cross-section, I want you just to write underneath it. It really just means slice, like a slice of bread. Pretend this is a loaf of bread and you're slicing it. The girth just means like the slice. And what shape do all the slices have? Yeah. So when it's talking about perimeter of a cross-section, what that means, just that little piece, the girth, that's going to be 4x. Perimeter, distance around. X plus X plus X plus X. That got nasty. So the girth is 4x. It's the perimeter of a slice, x plus x plus x plus x. And then you also have the length, which some of you might not have realized that's the depth. So it was a little nasty as far as it would have been a lot nicer if they had said something like y plus 4x is 108, right? But the clue ultimately was y plus 4x is 108. So I have a box that I'm sending where the maximum size is y plus 4x equals 108. Okay, letter A. Did you guys figure out that you were supposed to think about geometry like we did with the cylinder in our note? Okay, rectangular solid. What's the volume formula? you could think bottom area times height, you could think base times depth, or you could think length times width times height. Yeah. So V is equal to length times width times height. Now here's the struggle. We're not supposed to keep L and W and H. So what were you guys able to plug in for L and W and H using the variables they gave you? Good, x, x, y. Or you could make that x squared y, right? X, x, y, or x squared y. Now, here's the struggle. They want V as a function of and x alone. Ah, who doesn't fit? Yeah, and in our notes, wasn't it like they wanted it of R and R alone and H didn't fit? Or they wanted a volume for the can of H and R didn't fit? What did we do if someone didn't fit? Looked for a place that would help us substitute it away. Now, we can't just strictly substitute right now, but we almost can. What do we have to do first? Get y alone. Now plug in, right? So we want to go back and look at that clue, but we want to get y by itself and then make that substitution. So now we're able to go ahead and make volume as a function of x and x alone. So in A, you might have gotten up to the x squared y and gotten stuck. It's because you didn't have the clue. That's okay. Once you have the clue, do you now understand how it's x squared times 108 minus 4x? Now we have volume as a function of x. So then what does, oh, domain. I apologize. The domain of the function. Are there any square roots?
No.
No. Any denominators?
No.
No. Any logarithms? All real numbers? No. We have to think like we did yesterday about the sphere, actually 2 days ago. The radius couldn't be negative. It wouldn't change. The radius couldn't be 0. It wouldn't be a sphere. So think about it this way. X can't be 0. There's no box. X can't be negative. We have like a black hole. Just kidding, not really, but we don't have a box. What's X need to be? Greater than 0. Wait a minute. How on earth am I knowing there's also a maximum to what X can be? No, X can't be 108, but you're close. Y can't be 0 either. Y has to be greater than 0. And if Y is greater than 0, well, what would X be if Y was 0? And it used up all the 108. Don't you have to use up the 108 and 4 x's and a y? So if y can't be 0, that's the lowest y can be, well then set y equal to 0 and see the highest x can be. It's going to be less than, it's not going to be able to be the equal because y can't be 0. But if y was 0, wouldn't you just have to divide 108 by 4? What happens if you divide 108 by 4? X equals 27. X has to be less than 27, because if x was 27, it uses up all 108 and there's nothing left for the y, so it has to be less than that. So yeah, this little clue, the maximum, kind of helped me figure out what the highest was x can be. And then the fact that x is an actual length, well, it couldn't go to 0 or below. Okay, whew, that was letter A. Now it gets easy, because letter B says to do what with that information? Graph it in your calculator. Why graph it in your calculator? I don't know, it just says graph it and get a nice window. Okay, graph it, get a nice picture. Oh, letter C. What are you supposed to do once you have it in your calculator with a nice zoom? Find the dimensions of the max. Here's the long story short. Let's see, when x is 0, everything is 0? Okay. Here's the long story short. You end up with something like, I think this, eventually, if you get a nice picture. And you're looking for the which you can find on your calculator. And when you get a maximum, it's going to be a point with an A and with a B, right? They want you to find dimensions. Who's who once you get that point from your calculator after you put this in to y1? Who's who? Who's your A going to be?
X.
Oh, totally. Yeah, right? It's this guy. And this guy is x. No big deal. Okay, so you're going to have your x, and that's one of the dimensions. You're going to have actually 2 dimensions. You're going to be missing y. Oh, so B is y, right? B is y1. And who's y1? Volume. So when you get this point out of your calculator, if I were you, I'd write it down. I'm not going to solve the whole thing for you. It's an odd. Oh, it's an even. Struggle. We should go get the right answer. But the x and then the v, you're going to have to take the volume, which is your y in your calculator. Well, I guess you could also just take your x and plug in. I guess you could find y that way. Or you could take your volume and your x and find y. There's lots of different equations that are just kind of like floating around by this point that would help you find y. But that would help you solve. Was number 66 not even in here? I don't think he was he?
Oh, wait, no.
Oh, he wasn't even in there for you guys to check the answer to. That's lame. Okay, I'm going to go ahead and get number 66 so you guys can see the answer to that. But, wrong one. I apologize. Oh my goodness gracious. Come on. There we go. Why don't you guys start peeking at number 68, because I know some of you guys had questions on that one too. Let me go find 66 so we can at least check the answer. And quick question, are there any other questions that we have besides 68 and then checking or having an answer for 66?
81.
81? Anything else? That was Joe's too. Okay, perfect. Go grab their homework sheet. They should have it. 1.4, right? Oh, here you go. Number 66, if you guys want to peek at it. They did exactly what we did. Length, width, height, x, x, y, got it. Took the clue, rearranged the clue, plugged in the clue, got it. Domain, they didn't show any of their rationale, but we got it. Once you put it in your graphing calculator, there's a max. Go use the feature to find it. And long story short, just so you guys can write it down in your colored pen and make sure it makes sense, x equals 18, y equals 36. At the end of the day, x equals 18, y equals 36. Joe, go ahead.
I have a thought. Isn't it like could be if we made it a cube, it can maximize all the volume.
If it was a cube, but sadly it's a rectangular solid. But I see what you're saying. There is an SAT like trick if you're trying to maximize, that the maximum of any sort of rectangular where there are no extra restrictions is to make it a cube. But the problem is in this one, they gave us the extra clue of 4x plus y has to equal 108. So that changes it, so a cube wasn't the best fit. If it was a cube, it would be 18 by 18 by 18. Or take those dimensions and then divide it by 4, or by 3. So it's a good idea. It's a good idea. Just didn't really work in this one. Number 68 is the next one. This one we did have in ours, so let's talk about him. As you guys were looking at him, he was really similar, except everything got kind of messy when they said a rectangle is bounded by. Some of you guys just tuned out. Did anybody actually put this in their calculator and figure out who he was? Oh, they gave you a picture. I'm sorry. How did I forget that? Do you guys see the rectangle in the semicircle in the picture? Okay. What got hard in this one is that the rectangle can change sizes. There's -6, +6. There's like a 6 up there too. And there's a rectangle. Some of you only saw the one rectangle they drew. Some of you only saw the one that they drew. So you like counted over and you were like, oh, hey, I know how big the rectangle is. And I get it. You took geometry and you like just looking at pictures and counting. Problem is, they were saying this is only one example of a rectangle that could be bounded. Wouldn't this rectangle also be bounded? Wouldn't this rectangle also be bounded? Wouldn't all the ones in between be bounded? So they weren't meaning to establish in your brain only one rectangle of this only one size. They were trying to say there are all sorts of different rectangles. And ultimately, this is leading up to a type of problem where it says, like, hey, find the max. They didn't ask you to do that in this one. But there are all sorts of different rectangles. You were supposed to keep this guy general and not establish him with whatever number you saw as the illustration. That's where it got hard. So if you were thinking of any rectangle, area equals geometry would tell you what? Base times height. Good. Now I need x's and y's. No. Don't use him. He's a clue. We'll use him in a second. He has to do with the outside. I need the rectangle. So let's take this general rectangle right here. If I was trying to find his area, and let's say that we weren't supposed to use whatever number you kind of estimated when you counted across. But let's say we were allowed to use that. It's actually where section 1.5 starts today. Because whenever you do a point, don't you go over x from the origin and up y? So if this is x and if this is y, question, what's the base of this rectangle? 2x. I know, I don't know. The base is 2 x's, right? What's the height? 1y. But wait a minute, I'm supposed to have a function of just, but who do I have? Plug it in, plug it in. And then maybe you guys kind of understand why. Oh, that's a question. I apologize. Why? Number 68. Put 2xy, then put 2x times the square rooty thing. That's the area formula. And then it says, what's the domain? Well, if you guys look at the actual picture itself, x is an actual length. It can't go below 0 for the same reason radius couldn't, for the same reason the box, what was that called, girth, couldn't. But why can't it go any bigger than 6? Yeah, you can think of it two ways. Look at the equation. I can't go bigger than 6 or else it's imaginary numbers. Or look at the picture and say I can't go bigger than 6 because, yeah, the rectangle's not inside anymore. So the smallest x can be is 0 because that's the smallest x value. And the biggest x can be is 6. Some of you guys might be thinking of negatives, except if we're talking about x as being the length. That's why we keep it between 0 and 6. All right, number 81, last one. He's down here somewhere. Oh my. There were a lot more problems I could have assigned, huh? 81 was the difference quotient, yeah? So let's go peek over here really quickly to our notes from yesterday. Let me get rid of these guys, that way they're not in my way. Never mind. The example from yesterday, you guys were supposed to use this guy to help inform how you do things like number 81, right? Did you have any other ones except for 81? I thought I gave you a couple. Okay, 77. He was an odd, though, which might have helped. And maybe he was kind of similar to the one we did in class. Okay. It is a hard thing, especially for people that are bad at function notation. So I won't call any of them easy per se. But he should have been a little bit easier. Give me one sec. Okay. Number 81 was nasty because it had a fraction in it, and that results in a complex fraction. So I'm leaving this over, over to the side. That way you guys can see the formula from yesterday and how the problem was supposed to work. Here's number 81 that says use it for this guy. I'm actually really surprised honors didn't ask about this one. They asked about 77. Okay, difference quotient formula, that guy, right there. Except, wait, they changed it a little bit. They said, no, do this guy. All right, fine, so we'll do this guy instead. This guy instead. He's a big old fraction with a minus and an x minus 3. Who don't I know that I need to go find? I don't think I need to go find x, but I do need g of x to go in, and I do need g of 3 to go in. Now, where am I going to go find g of x?
Right there.
Oh, easy. 1 over x squared. It's a 1, not a 7. Where do I find this guy? Plug it in. So if you need to, you can do it off to the side. That was kind of useful for me. I went off to the side because this was complicated to plug in for that. Maybe some of you would have been able to do this a little bit easier, but remember, wherever the x is, that's where I'm plugging into. So 1 over who squared? 1 over 3 squared, which is 1 over 9. Okay. Why don't you like it if you were able to get that far? Complex fractions. Complex fractions. Now, I have a trick for complex fractions. I actually learned it in Uganda when I went there with Mr. Park, like the first year that Heritage was Heritage. We'll put it that way. Or the first summer that Heritage was Heritage. And no, there was a mission trip. Those are ones. I'm done. Okay, so what else do you do, right? I don't know. The smartboard is really mad right about here. No. Oh, well, that's true too. But, sorry. I get used to it. Is that what you're annoyed by? Anyway. I oriented it yesterday and that still happens, so I'm just going for it. Here's my cool trick with complex fractions, but I can show you. No, I won't show you. Maybe I'll show you tomorrow. The long way, because the long way is super annoying, and it's why none of you remember it. And so you're all mad at this problem, or at least frustrated with it. Ready? Here's the trick. The trick is to ask yourself, who are the two little denominators that are messing me up right now? Those guys. I don't like them. So what are you going to do? What am I going to do? Multiply top and bottom by them. Put big old parentheses so I don't get messed up. Wait, is it legal to multiply something by the same thing, top and bottom? Yeah. Totally. I can multiply by 5 over 5, 2 over 2, 1 over 1. Don't know why I would. Or 9x squared over 9x squared. Why? It makes everything nicer. Because if I distribute the 9x squared here, wouldn't I get 9x squared over x squared? And then here, I would get minus 9x squared over 9. What's going to happen if I go simplifying? The x squareds cancel in one, the 9s cancel in the other. I still have my 9x squared times x minus 3. But what's left? Just a 9, just an x squared. This guy. Don't kill kittens and say, hey, there are 9s. Hey, there are x. Don't do that. Please, please, please. But what can you do? You can go ahead and do something like, if you pull out a negative, I'm just going real fast because that's not the order that we want it in. We want it to be that way. So I pull out a negative, but pretty soon with factoring, some of you saw it, I am allowed to legally get rid of somebody. But then I'm going to be stuck with the rest. I would go down, except this guy doesn't go down. Sorry. Negative x plus 3, or you could have negative x minus 3. I don't think you can go any further than that. But you guys can check the odd. You can check the Calc Chat version or the back of the book and see. Maybe they did the negative x minus 3. Maybe they left it way back here. I don't know. Possible. But that's how you plug in to the difference quotient with a nasty fraction where you have to simplify. Okay. Whew. Nice thing is, section 1.5, we do have 3 days on it. Today we're going to still get into it just a little bit. Then we have tomorrow and we have next Tuesday. The homework is technically, I think, due next Wednesday because Monday is a holiday. But we do need to at least start it. So if you guys do have further questions on homework, you need further clarification, et cetera, et cetera, et cetera. There we go. We're going to have to table it for right now. Let's get back into our notes. Difference quotient, it's hard. I understand that. So if the example from yesterday, watching me in the video last night, trying it on your own wasn't enough, come by. I'll give you a little baby whiteboard and we'll do some practice. Okay? So I get that the difference quotient's hard. I'm sorry. It is. But it's not impossible. Just some of you might need a little more practice. If section 1.5 is due next Wednesday, and 1.5 is the last section before the test, that means the test is like next Thursday or Friday-ish, right? We talked about it yesterday. It's okay. That's why I keep saying these things. That way those of you who just kind of hear me and then ignore me maybe can remember. But it's also in your class calendar if you look there as well. Bless you. This is exactly what I was talking about with that boxy one in the semicircle. Oh, hey, remember x is how far over, y is how far up? The dotted lines are just to show you what they're talking about as far as the point they're going to. The pink is never the graph. The pink is just like describing what's going on. And I know it's kind of silly to think x is over and y is up, but as you saw, that rectangle in a semicircle, that was kind of hard. figuring out that the area, the base was 2x and the height was y. So that's one of the reasons why we have that reminder. Sorry, I keep on trying to take a roll and it's not working. Roll real fast. We do have quite a few groups of 2, so probably next week we might rearrange the seating just a little bit so that groups of 2 can turn into groups of 3, but just letting you guys know that's coming. I think we're good otherwise. Okay. I didn't really notice it until yesterday. I'm like, oh, we have like 2 and 2 and 2 and 2. Sorry about that. All right, if x is how far over and y is how far up, what else is there to section 1.5? Well, let's get through interval notation today. Let me go ahead and bring this guy back down until the maintenance guys can fix my projector. We're kind of stuck with it where it is. There we go. Interval notation. He's going to end up being basically our main idea of today in section 1.5. There's so many other things, but the nice thing is today, just interval notation. On that second slide, what do you guys see in all the examples? What are those? Yeah, less than or equal to's, greater than or equal to's. What are those called? What's like the general category? Inequalities. Interval notation says inequalities are good, but they're not the only way. I think you might have seen this a little bit last year. Interval notation says inequalities are good, but they're not the only way. They say instead of using less thans and greater thans, we can use parentheses and brackets. I shouldn't even say less than and greater thans. Instead of using inequalities or equal to's, so less than, greater thans, or less than or equal to, greater than or equal to's. Instead of using those, we can use parentheses, brackets, and commas. Parentheses, brackets, and commas. And parenthesis is specifically talking about not equal to, and I just crossed it out, that's fun. Parenthesis is talking about not equal to. Brackets are talking about equal to. And depending on whether it's on the left or whether it's on the right, it talks about greater than or less than. So if we were to think about like a number line, we would have an open circle at -2. We would have a closed circle at 5, and x could be anything in between. That's what this is, the inequality. How we show that in intervals is we do something to the effect of parenthesis -2, comma, 5, bracket. Now technically you don't know if it's an x or a y or an a or a b unless you put a little variable with a little e. X is an element of, x is within. But -2 is the left, 5 is the right, bound or boundaries. Not allowed to be not or equal to -2, equal to 5. And if we follow that pattern, in this one in letter B, how far left on the number line or how low on the number line can we go if we're talking about greater than or equal to 3? How left? 3, yeah. So 3 is the boundary and it's allowed to be there, so I do a bracket. But wait a minute, how do we answer the how far right question? Good, and we actually put that because we need to have a boundary. Why do you think I put a... You can't get there. You can't land there. It's more of like where you're headed. And this one, if we have less than 1, how left do you go on less than 1? But infinity in the other direction? And how right do you go? But are you allowed to hit 1? So who are we going to put? Got it. Interval notation. You might not be able to start homework very much, so maybe you want to catch up on another class tonight and not stress about pre-cal so much. Or maybe you need to catch up on homework questions from last night. Bye guys, I'll see you later. 1.4 was a little bit rough. Hang in there.